Okay. Now, this is the derivation of governor. You have to find out in Hartnell governor. You have to find out the stiffness of the spring. Now, what is the stiffness?
The screen is not visible.
1 minute. Is it visible?
Yes.
Yes, sir.
Yes.
Okay, now in spin control governor, we will see only one governor, Hartnell governor. Okay, now in Hartnell governor, you have to find out the stiffness of the spring. What is the stiffness of spring? Net load per unit deflection. Now you have to calculate the net load using the formula S2 minus S1. S2 is a spring force exerted on the sleeve when the speed increases or maximum speed, and S1 is the spring force exerted on the sleeve when the speed decreases or at the minimum speed. And H is the deflection of the spring when there is a variation in the speed from S1 to S2. Deflection of the spring when the speed increases from S1 to S2. Okay, I have to find out this H formula given here, R2 minus R1 into Y by X. R2 is the maximum radius at maximum speed, R1 is the minimum radius at minimum speed. Now what is this Y and X? Anyone?
Sir, there is lot of disturbance.
Hello? Hello? Am I audible?
सर आपकी वॉइस ब्रेक हो रही है सर.
सर वो माइक का आवाज आ रहा है पर.
एक मिनट.
और सर आवाज आ रही है सर.
Okay? Am I audible?
Yes sir.
It is okay.
Okay, now in this Hartnell governor, you have to find out net load per unit deflection. Okay, means stiffness find out करना है आपको यहाँ पे. Okay, net load कैसे निकालना है? S2 minus S1. S2 is a spring force exerted on the sleeve at maximum speed, and S1 is a spring force exerted on the sleeve at minimum speed, and H is the deflection of spring. Okay, and deflection of spring you have to find out by using the formula R2 minus R1 into Y by X. Now tell me what is this Y and X? What is this Y and X?
Sir, Y is length of the ball and X is length of the sleeve.
Y is the length of the ball arm or vertical arm, and X is the length of the sleeve arm or horizontal arm. Okay. Next, if you consider the friction, you have to add or subtract the frictional force in weight of the sleeve. Okay. But we will see the numericals without considering weight of the sleeve. Okay. Now you have to find out the stiffness at the various positions. Means suppose the radius of rotation changes from minimum to intermediate position, you will get this formula. Then intermediate position to maximum position, you will get this formula, and minimum to maximum position, you will get the formula. Okay, I have to combine all the stiffness because the stiffness is same for the various position. I have to combine this formula. Okay, now see the last one. This one. Okay. Okay, now see the numerical. All of you write down this problem. Do it fast. Today or tomorrow I will send the Google Classroom link. What you upload the previous notes. I will tell you 5 lecture notes in one PDF. You have to put the name of this PDF as your role name.
Sir, you are not audible clear.
Hello? Hello?
सर आपकी वॉइस ब्रेक हो रही है सर.
1 minute.
बैकग्राउंड नॉइज आ रहा
सर कर आवाज है.
अरे बारिश बहुत है यार. Hello? 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 Yes, sir.
Yes, sir.
क्वेश्चन नहीं दिख रहा है.
Okay, 1 minute. Is it visible?
Yes, sir.
Am I audible?
Yes, sir.
Okay, now see the question. Now it is given here in a spring loaded Hartnell governor. Okay, now in exam there are two types of questions. Either the question is asked on Porter governor or Hartnell governor. Okay, now it is mentioned in this numerical. Now first of all see or find out which type of governor is given. Now in this case spring loaded Hartnell governor is given. The extreme radius of rotation of the ball are 80 mm and 120 mm. Means what is given here? R1 and R2. Extreme means minimum is R1 80 mm, maximum is your R2 120 mm. The ball arm and sleeve arm of the bell crank lever are equal in beam. Means what is given here? Ball arm and sleeve arm means X is equal to Y is given here. The mass of each ball is 2 kg. Means small m is 2 kg. If the speed at the two extreme positions are means minimum speed n1 and maximum speed n2 are given here. N1 is given 400 and n2 is given 420 rpm. Now you have to find out here the initial compression of the central spring. Means you have to find out the initial compression at minimum speed, okay, and the spring constant. You have to find out here stiffness. Yes, all of you note down this given data. Okay. Okay, now the speed is given in RPM. We require the speed in radian per second. You have to convert it into radian per second. 2 pi n upon 60. Do it fast. Convert all the radius into meter, then speed into radian per second. Okay, done all of you? Dipanjan?
Yes, sir.
Okay?
Given liters. Given
Okay.
liters.
Okay. All of you note down the problem. Okay, now how can solve this problem? Anyone? In this case, you have to find out first of all S1 at minimum speed and S2 at maximum speed. Same as previous, taking moment about the fulcrum. Okay, means suppose you consider here the minimum and maximum position. I'll draw here the minimum position first. Now this is the equilibrium position. Okay, now this is the vertical axis. When the link moves in inward direction at equilibrium position or at minimum speed, it moves inward direction.
Here we go.
Shashwat,
Yes.
is there any doubt?
Not yet.
Okay. Okay, now when the speed is decreased, the fly ball goes inward direction and the various forces acting on the lever on fly ball, there will be centrifugal force FC1. Okay, now the load acting on the roller is your capital mg plus S1 divided by 2. Okay, now the length of the vertical arm is x and length of the horizontal arm is y. Okay, now in the given problem, length of vertical and horizontal arm are given here equal. Okay, now this is for minimum position, and for maximum position means when the speed is increased, sleeve moves outward direction. Okay, and roller moves upward direction. Now force acting on this roller is your capital mg plus S2 capital mg plus s2 divided by 2. Okay, and force acting on this roller is your centrifugal force Fc. Now, on downward direction, weight of the fireball means small mg is acting. Same for the minimum radius also. And the lift of the sleeve is total lift is your h1 plus h2h. Okay, now in this numerical, first of all, you have to find out the centrifugal force for both cases. क्या find out करना है? First of all, you have to find out the centrifugal force at minimum speed means fc1 and maximum speed is fc2. Now tell me the formula to find out the centrifugal force at minimum speed. fc1 is equal to
M into omega 1 square R1.
correct. fc1 is equal to m r1 omega 1 square. Okay, r1 is given here 0.08 meter. Omega 1 is here. You have to calculate omega 1 by using the speed n1 400 mm. You will get here 41.9 radian per second. And similarly, you have to find out the centrifugal force at maximum speed fc2. Only you have to replace here r1 to r2 and omega 1 to omega 2, because we find out the fc2 for the maximum speed m r2 omega 2 square. Again r2 and omega 2 is given. Okay, then you have to find out the s1 and s2. S1 is a spring force at minimum speed and s2 is a spring force at maximum speed. Now first of all, tell me fc1 and fc2. fc1 कितना आ रहा है?
6.704.
fc1 is in Newton. Tell me the answer.
6.704.
6.
6.704.
6.70. Okay, and fc2. I'll have to cross check this answer. fc2. हाँ देवांग do it fast. Mass is given here. Mass is same 2 kg. Hello. Dipanjal?
Sir, 10.55.
Correct. 10.5. When the speed increases, centrifugal force also increases. Now you have to find out the spring force S1 and S2. कैसे find out करेंगे? Anyone? See the figure. For minimum speed, you have to taking the moment about O. Then maximum speed, you have to taking the moment about O. Okay, you will get this equation. You have to refer the previous equations. Again, neglecting obliquity effect, you have to always neglect the obliquity effect of arm. Means you have to consider x is equal to x1 is equal to x2 and y is equal to y1 is equal to y2, and moment due to the mass of fly ball, you have to neglect it. Means if you consider here the minimum position, okay, or you have to consider here r1, what is the equation? Anyone? fc1 into क्या आएगा? fc1 into x, correct, is equal to capital mg plus s1 upon 2 into y. Again, if you see in the numerical, x and y are given same, it get cancelled. Then mass of sleeve is not given, it get cancelled. Directly you will get here S1 is equal to 2FC1. FC1. Similarly, you will get S2 is equal to 2FC2. Okay? Numerical here. We know that for minimum position, mg plus S1 is equal to 2FC1 into y by x or x by y. Means you have to find out S1 is equal to 2FC1. Either you have to directly write down the equation, okay? Otherwise, you have to taking a moment about you have to write down the equation. Okay, I'll draw figure. कितना आ रहा है? How much?
परत एक्सप्लेन करा ना.
S1 is equal to okay, either you have to directly write down from the previous cases. Okay, direct equation लिख सकते हो. Otherwise, you have to taking a moment about for minimum position. You have to consider that this minimum position. Okay, I'll take a moment. Moment कैसे लेना है? mg into S1 divided by 2. If you see here, mg plus S1 divided by 2 into distance क्या है? Into y. Okay, is equal to, because this force goes clockwise and FC goes anti-clockwise. FC1 into क्या आएगा? Distance क्या आएगा? Into x. Okay, ये वाला distance x and mg का a वाला distance. Okay, if you see in the numerical x is equal to y given means ये cancel हो जाएगा. Then mass of the sleeve is not given, a cancel हो जाएगा. means रह गया क्या? S1 is equal to 2FC1. Got it? Or understand?
Yes, sir.
Now note down this and tell me the answer. It is not compulsory to draw the figure. If you remember this formula, you can directly write down. Similarly, maximum speed. Maximum speed के लिए क्या करना है? You have to replace only S1 to S2 and FC1 to FC2. Maximum speed. This क्या आएगा? S2 is equal to 2FC2. कितना आ रहा है? डबल करना है बस. 12 और 13 point. How much? S1 is equal to S1.
13.4.
Correct. 13.4. Similarly, find out for S2. Okay, S2 क्या आएगा यहाँ पे? S2 is equal to 2FC2. If you take a moment about O, you will get the same equation. Moment due to mg is here. In the formula, we do not consider this mg because we neglect the obliquity effect. Means moment due to the mass of fly ball we neglect here. S2 कितना आएगा? डबल हो जाएगा. Means 21.
21.
Okay, 20 meter. Write down the unit. Okay. Now here similarly for maximum position we will get the H2. Now we know the lift of the sleeve. How can I find out the lift of the sleeve? H is equal to
सर FC1 कितना आ रहा है?
कितना? कौन सा?
FC1
FC1 is your 6.7.
और मेरा 280.89 आ रहा है.
280 point
Yes,
और
I'm
FC2
280.89
कितना?
280.89 आ रहा है मेरा.
Okay. These answers are wrong. फिर से बता मुझे FC1 FC2.
FC1 280.8.
1 minute. FC1 is 280.8 Newton. Okay. And FC2
460.42.
460.2. Yes, correct.
4 sir.
480.
464.
464.
0.21.
फिर ये 280 कैसे आया फिर? हेलो, FC1 is 280. Is that correct?
Yes sir.
और ये FC2 400.
60.42.
आवाज नहीं आ रही ठीक से.
460.42.
460 correct. 460 point something. Now you have to calculate this S1. Okay, do the calculations yourself. S1 कितना आ रहा है? अभी डबल हो जाएगा.
S1 561.6.
561.
Yes,
Correct. S1 is 561 and S2 is
928.42.
928. Correct. I'll have to note down these answers. 928 is the S2 and S1 is 561. Now you have to find out H. Lift of the sleeve. क्या है formula? H is equal to R2 minus R1. R2 minus R1 into Y by X or X by Y.
X by Y.
Check this.
Sir, Y by X.
Correct. Y by X. Now this Y and X are same. It get cancelled. R2 minus R1 is the H. You have to tell me the answer in meter. कितना आ रहा है? R2 is given, R1 is given.
Zero point zero four.
0.04.
0.04 or 2.
H 0.04.
0.02.
0.04.
4 और 2. R1 कितना दिया है? 400 means 0.4 और R2 0.02 is the correct answer ना?
Sir, R2 0.12 मीटर दिया है ना और R1 0.08.
हाँ तो कितना आ रहा है?
0.04 आ रहा है.
0.04. Here is the answer. 0.04. Now you have to find out the thickness of the springs. Thickness of spring कैसे निकालेंगे? Net load S2 minus S1 upon deflection H कितना है हमारा? 0.04. कितना रहा thickness? आयुष ठाकुर कितना रहा? Anyone? Hello.
सर 917
9175.
9
न्यूटन
point
पर मीटर 9
repeat
पॉइंट
again.
हाँ
9 point.
सर mm च्या टर्म्स में लाए थे कि
You have to convert it to meter. Meter में बताओ.
तो 9170.5 न्यूटन
9170.5.
0.5 हाँ
0.5 न्यूटन
न्यूटन
पर
पर
मीटर. करेक्ट. न्यूटन पर मीटर. और एमए में कितना आएगा फिर? 9.1.
9.17
17 or 4 something Newton per mm. Okay, now you have to find out, this is the thickness of the spring, and next term you have to find out the initial compression of the spring. Initial compression, when this initial compression takes place at the minimum speed. Initial compression takes place at the minimum speed. Means you have to write down your formula. This is the formula S1 upon S. Initial compression of the spring. If final compression, then S2 you have to put here. Kitna raha? S1 is known here. S is known here. Now tell me, if you have taken you have taken answer in Newton per meter, then you have to consider Newton per meter. और mm में लिया तो mm देना. कितना रहा initial compression?
One point zero two.
61.02 mm. Correct. Initial compression is the 61.02. Now find out, anyone find out the final compression? S2 upon S. मीटर में क्या था? 0.061 आएगा.
101.24.
Compression is 100.91.
100.9.
91. Yes.
पॉइंट में आ रहा है या नहीं?
Point में आ रहा है 100.9.
हाँ 100.9 करेक्ट. 100.9 mm. Okay, now this is the final compression. This is the initial compression of this thing. Okay, done. Now take down the next one. Note down this problem. Now see what is given here. A Hartnell governor having a central sleeve spring and two right angle bell crank levers moves between 290 rpm to 310 rpm. Means N1 and N2 are given here. You have to find out omega 1 and omega 2. For a sleeve lift of 15 mm, sleeve lift directly there H 15 mm, point not 15 meter. The sleeve arm and the ball arm are 80 mm and 120 mm. Sleeve arm means your vertical arm X 80 mm. Sleeve arm means your horizontal arm Y 80 mm and ball arm means your vertical arm X 120 mm respectively. The levers are pivoted at 120 mm from the governor axis and mass of each ball is 2.5 kg. Now what is this 120 mm? Anyone? What is this 120? Which one? Minimum, maximum or intermediate? Which radius? Now it is given ना, lever are pivoted at the 120 mm. Means यहाँ पे मैंने अगर figure निकाला, this is the equilibrium position. Now this is the pivoted point. Means ये distance दिया है यहाँ, R equilibrium position. Am I right? Levers are pivoted at 120 mm from the governor. Governor axis से pivoted point मेरा वो यहाँ पे pivot किया है. Okay? Means R is given 120 mm, means 0.20 meter. Now what is the next sentence here? The ball arm are parallel to the governor axis at lowest equilibrium speed. Means what? Ball arm are parallel to the governor axis at the lowest equilibrium position. Means this is the position of lowest equilibrium. Means R is equal to R1 here. Am I right? Are you understand? समझ में आ रहा है कि नहीं आ रहा है? See these two sentences. तुषार, विनोद, यश, समझ में आ रहा है कि नहीं? हेलो, आदित्य.
Yes, sir. Yes, sir.
This condition, you understand this condition? Lever are pivoted on the 120 mm from the governor axis. Means suppose say governor axis का then one arm one arm is vertical. Means
सर
yes.
सर तुमचा आवाज नीट नाही.
सर आवाज ब्रेक होतो तुमचा.
अरे बहुत बारिश है यहाँ पे. Now check. Hello. Hello.
येस सर आता येतोय.
येस
Okay, समझ में आया R1 and R? R1 and R समझ में आया? Hello. Yes or no?
सर परत एकदा सांगा ना.
Now see here. Now one sentence is given here in numerical. Levers are pivoted at 120 mm from the governor axis. Means suppose मैंने यहाँ पे figure draw किया. Now lever is pivoted. Bell crank lever is pivoted at O, and its distance from governor axis is given R, 120 mm. This one, 120 mm. And next sentence is given. The ball arm are parallel to the governor axis at lowest equilibrium speeds. Means मेरा जब minimum speed रहेगा, the ball arm जो है vertical arm is parallel to the governor axis. Means it is at the equilibrium position. Means minimum radius and equilibrium radius both are same. Means आपका lower speed start from the equilibrium position. Okay, R is equal to R1. You have to calculate here FC1 and FC2. Okay, from the speed N1 you have to find out omega 1, N2 you have to find out omega 2. Okay, all of you write down the given data. Now H is given here, and what is given here? Y and X are given here, and R is given also here. Okay, R is equal to 0.12 meter, or you can say it is R1. R1 is equal to R is equal to 0.12 meter, and mass of the fly ball is given here. All of you note down this given data. Okay, done. Now to find out the spring force at the lowest equilibrium position, we know R is equal to R1. It is very easy to find out the speed at lowest equilibrium position. Okay, and S2 at spring load at highest equilibrium position. Now since the ball arm are parallel to the governor axis as lowest equilibrium position, you have to consider the same condition. Okay, and you have to find out here. Okay, you have to find out here S1 and S2. Tell me how to find out here FC2. Or first of all, you have to find out FC1. FC1 is equal to MR1 omega 1 square. Tell me the answer. Then you have to find out for maximum.
हॅलो सर तुमचा आवाज ब्रेक होतोय सर.
कायच आवाज येत नाही सर.
Hello.
Background noise too much.
Hello, Shashwat. Am I audible? Hello.
Yes, right now you are.
Yes, sir. Yes.
Just put somewhere else on the screen so I can see the whole question.
Okay, now you have to first of all find out FC1. कितना रहा FC1?
276.5.
276.5 Newton. Okay, now you have to find out FC2. FC2 is equal to mR2 omega 2 square. Is there a R2 given in numerical?
No, sir.
How can find out R2, anyone? Means this is the maximum position. Find out FC2.
So we have H, X, and Y.
Correct.
And R1.
We know the lift of the sleeve. We know lift of the sleeve H is equal to R2 minus R1.
Y upon X.
Correct. Y by X. Okay, we know Y is given here 0.08, X is given here 0.12, R1 is here 0.12, H is given here. How much is the H? 0.05, 15.
0.015.
R1, sorry, R2 कितना रहा है? 0.
0.1425.
142. It is always greater than R1. Okay, 0.14. Now you have to find out FC2. कितना रहा है? कितना है? FC2
368.7.
36 8.7.
7.
Is it correct?
372.
372. Now you can write 372. Okay, we know your FC1, FC2. Then you are to taking a moment about O for minimum position and maximum position. You have to write down the equation. Okay. H निकाला यहाँ पे. Okay, now find out the centrifugal force 2. Neglecting obliquity effect, you have to write down the equation mg plus s1 is equal to 2fc1 into xyy. For minimum position, s1 find out करना है. Okay. For minimum position, you have to taking a moment about O. क्या आएगा? mg plus s1 upon y is equal to 2fc1 into x. Write down the equation in terms of mg plus s1. Always you have to neglect this mass of sleeve.
S1 you have to find out, FC1 निकाला, X दिया है, Y दिया है. Now you have to find out this S1. हाँ कितना रहा है S1? S1 is equal to, hello, hello,
Hello, sir.
हाँ S1 is equal to कितना रहा है?
8 to 9.5.
How much? 8 to 8.
8 to 9.5.
8 to 9. 8 to 9.5. Okay. Similarly, find out S2. S2 के लिए क्या आएगा? mg plus S2. Again, mg you have to neglect here. Capital mg is equal to 2fc2 x by y. Okay. Find out. Again यहाँ पे mg गया. S2 कितना आ रहा है?
1128.
Repeat again.
1128.
1128 Newton. Now check this answer. Okay, once you will get the S1, S2, you have to find out the stiffness of the spring. S2 minus S1 upon H. S2 minus S1 upon H.
So 19.9.
19.9, correct. 19.9 mm,
Yes, sir. Mm.
correct. Newton per mm. Okay, done. Hello. Okay, all of you mark your attendance first.
Yes, sir.
Mark your attendance. I will circulate in. Mark your attendance. Your mark proxy. So the next point is performance characteristics of the governor. So first one is sensitiveness of governor. Tell me what is meant by sensitiveness.
तुमचा आवाज खूप स्लो येतोय.
What is meant by sensitiveness? Hello. 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 Hello.
Yes, sir.
What is meant by sensitiveness? Anyone? Sensitiveness means what? Hello. Hello.
Would be a governor's response to changes in speed,
Hello.
change in RPM.
Hello.
Yes.
सर आपकी आवाज बहुत स्लो आ रही है.
We will finish within 5 minutes. Okay? Now tell me what is meant by sensitiveness of governor. Hello. Hello. Hello.
It's how easily the governor responds to changes in RPM. There's a governor supposed to keep a certain range of RPM. Not working.
Okay, Shashwat, we will stop here. Okay. We will continue this point in the next lecture.